Everyone, we will solve this today's LeetCode problem. The question is minimum swaps to group all 1's together, two, right? So this is a LeetCode medium. Let's see what the question is asking. So we have given a swap which is defined as two distinct positions in an array and swapping the values in them, right? A circular array is defined as an array where we consider the first element and the last element to be adjacent. Given a binary circular array nums, return the minimum number of swaps required to group all 1's present in the array together at any location. Okay, so let's analyze what the question is asking. That first thing is to that a swap means here that we can choose any two position, right? The first thing to note that we can choose any two position and swap them, right? Any two positions and swap them, right? Swap the values and that position, right? The first thing to note at the second thing, that a circular array is given. What does it mean, circular array? That the last element, this zero and this one, this zero and this zero, if you see the first example, this n minus one and the zeroth element, it's adjacent to each other, right? It means it is a circular array and we can move from last to first element, right? It is a circular array, right? The third thing is to note that what we need to find, we need to find the minimum number of swaps required to group all ones present in the array together at any location, right? We need to group all ones present in this array at any location, and we need to do with the swaps, and we need to find minimum required to number of swaps required to do this, right? So how we will simply do that, right? So basically, here if you see in the first example, is itself explanatory that this one is a group and this one is a group, right? So for making all the oneness group together, we need to move one, either this one, this one and this one, right? So what will the minimum swaps to group all the ones? And we can group all the one at any location. Either you swap this one to here, so either it is possible that this will become like this, or you can write like this, right? Write like this, or you can simply do like this also, right? Right, you can write like this also, right? So basically, what we need to simply swap. So for this swap, right, for this swap, that in this swap what I have done, I have simply swap this one value to this with this adjacent value, so it has a one swap, right? And it is grouped together. And in this, I have done, I have swapped this two values to its I have swapped this one value to this one value. I have swapped this one value to this position, because we can swap any positions values. So I have swapped this let's make this 0 0 1 and 2 3 4 5 and 6, right? I have swapped this 2th value with this 4, so it is also taking one swap. In this, what I have done, I have swapped with this one with this 0, then with this one, this with one, this 3 with 1, and this fourth position with 2. That's why this one occurs. So how many swaps I have done? 3, right? So what are the minimum swaps required? Minimum swaps required to make all the group together is 1, right? So answer is 1, right? Now you understood the questions, right? Now now one thing you see that that if I need to make a swap and I need to make minimum number of swaps, so one thing is to note that I will not move the largest group which is all together, right? This one, so moving, so move the swapping swap swapping the swapping the large group of ones in array is not feasible, right? Is not feasible, or you can is not feasible, or you can means ये worth it नहीं है ना, is not worth it, right? Is not feasible or worth it, right? To move, right? We should move, because we can group all together at any location, and we need to find the minimum number of swaps. So can we simply swap, we can simply swap we can simply swap those one those one which is not a part of the larger group of ones which is given in the initial array, which is in the initial array, in the given array, given initial array, right? That's the thing here, right? Simply those one which is not a part of the larger group. So basically, if you see that we can swap at any position to anyone. So one thing is to know that if I take random, like suppose this is zero, this is one, 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 this zero, 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 one, 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 then let's take another one, then again zero, zero, and this is one, right? So what are the minimum number swaps to group all together? So one thing is to know that do you need to move this, right? If you move this, so you need to take four swaps, right? If you move this, but if you move this, you need to take only two swaps. If you move this, you need to take only one swap, right? How two swaps? One, you can one place at here, one place at here, but if you move this, you need to take four swaps. So if you see that how many swaps would get together, the minimum number of swaps would be for this will be the two, and this will be the one. So this will be the total number of swaps is three. What I've done, I've not swapped this. I am just I have just uh, swapping other ones which is not in the part of this group, and calculating the number of ones here, right? So basically it is something like number of ones, total number of ones, total number of ones, which is equals to 1 2 3 4 5 4 plus 2 6 1 7, which is 7, and which is and this is the larger part of group which is 4, right? Group of one, large group of ones, right? Large group of ones, which is 4. And basically what will be the answer? 7 minus 4, which is not a part of this large group. That much swaps is needed because that much one has left to be here, right? Here we can swap to any position, right? We can swap to any position, so it doesn't need to calculate it, because I can swap this one to this here, I can swap this one to till here, anywhere, right? So it's like only one swap, right? So that was the number of count of ones, right? So that's the answer is 3. So basically the approach is simply, so what will the final approach? So approach is that find we will find the large number of the max subarray, which max subarray length, which contains the ones, right? Max subarray length which contains the ones, and also also calculate calculate the total number of ones present in array, right? And what we will do, we will and answer would be just total ones minus this max length, right? This max length, and that would be the answer. Understood? Why this is the answer? Because we need to find the minimum number of swaps. So why we simply why will make them make changes in the large number of groups of ones, right? We don't need this. We can change only the part which the number of the ones which are not part of this, and that must swap. We need to just group all the ones together. Now the thing is, how will we find the max subarray length which contains the ones, right? Okay. And also remember that array is a circular array. Array is circular array, right? Array is circular array, right? And now the thing is, if array is a circular array, then it can be possible that this case is also possible, right? This one, this zero, this one, and this one, and this zero. So what is the maximum length of subarray which contains the ones? It is not 2, it is 4. Why? Because 1 1 and this 1 1 is all grouped together, right? This 1 1 and this 1 1 is all grouped together. So it's just a question. Now the question is just to find the max length of subarray of ones present in circular subarray. And this is a standard problem, you can say that. and you have must have solved that if you have used sliding window approach, right? So basically what we do, we will use sliding window approach to find this, right? So whenever you find to make the maximum length of sub array, or whenever you need to find the length of sub arrays, and the where they, if there is anything related to sub array, think of sliding window. Think of sliding window. That's the simple thing. Think of sliding window at whether it is applicable or not, right? So sliding window approach, what does it take? So what we will do, we will just check. We will, in the sliding window approach, we will just start iterating and find start iterating and make the current window, make and check for each window, and check for each window that at which window we get the max number of 1s, right? And store that, right? Simply. So how this will get one? So how we will know that whether we need to move back or not, right? So basically, one thing is to know that we have calculated the total count of one, right? So if you see one thing, that that till which from 0 to n is the original array, but we need to also check like this 1 1 and this 1 1. So I need to traverse again, right? So either you make a duplicate like this, make a duplicate like this to the separate array, the same array, the same you can either you can make like this, either you can again duplicate this and store in other array and do the sliding window on this, or one thing's to know that what is the maximum possible of count of ones, right? So let's take the maximum count of as 1, max count, max count. So so suppose I will just move to n plus k. And what is k? K is k is max count, total count of 1 1s. And why I'm saying that, because we need to find the total number of 1s. So if I just go through this total count, n plus k, it means there are there are cases like this: 0 0 0, sorry, 1 1 and 0 0 0 0, and this is 1 and 1. If the case is like this, where all the 1 is considered, all 1s and the total number of ones are in this circular array like this, so this will cover. And if this is not case, then it will also not nothing need to do with us, right? So this is why we don't need to traverse till 2 into n. We can traverse it to till o of 0 to n plus k, right? And what we will do, we will just start make a just make a start a window, just make a starting window which will be the first group, the first group, right? That will be the first group. And what can be the first group? Anything. Suppose I take 0 1 1, and this is 0, this 0, and this is 1 and 1 and 0, right? So the first window will be what? So if you take the first window as o of k, which is total count, right? So total count is 5, right? And if the total count is 5, and if I take the total count as the first sliding window, the first sliding window, if I take it, so can we simply mark it as my starting window point, right? Can we mark it? Yes, I can mark it, right? Simply. So what I will do, I will just see that what will the my starting window, which will equals to k, right? For sure, right? Right. So that's what I do. I will simply mark it as my first starting window. So what I will do, I will just go through this 0 to k and see that what will the first starting window, because this can be the why I'm taking this k5, because the first window can have maximum of 5 ones only, right? the first window the first window can have max till k ones, right, or less than this, right? So we will consider that, right? So what I will do, I will just make the starting window, which will be start window, which will be to till k5. So we will start from 0, 1, 2, 3, 4, 5. So there are 3. So I have 3 till k5, right? Till 5 means 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And what I will do, I will simply apply the sliding window, which will start from this k till n plus k, right? Right. And what I will do, I will move through go through from 5 till 8, sorry, till 8 plus, which is 8 plus 5, which is 30, right? Right. 8 plus 1, which is 30. This is 30, right? That's what we're gonna do. Now we have started from 5. We have calculated our count as till this here. The start window is 3. The starting count, this is count of 1, right? 1 is 3, right, till here. Now after this 5, when we move to starting on 5, we will slide this window. So till here this 5 count is one window, and now we are moving to this window, right? So we will shift this window. So this is the first window. Now start with 5. So when you consider this 5 as an element in the next window, you need to delete this one. So if you need to check that whether it is 1 or not, it is not 1, so we will not decrease the 1. And either if it is 1, we will add this, right? So this 5 is nothing, right? This 5 is nothing. Then we move to 6. Now when you move to 6, this 1 has 1, right? It means you need to minus this count to 2, plus you need to add this count 6, right? Because in your current, in your windows, there must be window is of 5, right? 5 length, right? Your windows length of 5. So what we do, you will need to consider this 5. So before it was 1, so delete it. And now it's now 6 has a 1, so add it, so count is still 3, right? Now again you move to 7, and you move till the here. So you see that you have still this 5 windows, and you need to just delete the second position, which is 1, and add the seventh one, which is here. So again it is nothing, which is 3, right? Now you move to 8, this, and see that the third has 1, so you need to delete this one, decrease the 1 count. But it has no one, so the count will be 2. So if you see, the maximum count was 3, right? In whole array, the max count of ones is 3, right? In the whole array, right? Now again one things to note, that we have moved till 8 here only, right? But we need to consider this n plus k. So when you start moving for 9, 10, 11, 12, 13, 14, like this, so because we need to check for further part now, we need to check for further part. So when you move to 9, it is representing this 0 index, right? So what will you do, we will just take this as like I modulus n. So what does it? Why does it help? N is the length of this array, which is 9, and 9 modulus 9 is 0, which is representing this. Same for 10, 9 modulus 10 modulus 9, which is representing 1. Same for this. So what I will done, I will not take simply I will take for I modulus n, right? So this helped me to reiterate this whole array and not maintaining this array, right? So that's what I will do. I will take I modulus n for that. So I will check for 9 also. So now when you check for 9, it means this 0 is included, right? Now this windows still move this 4 plus this 1, right? So still if you move this here, the previous one 0, and this is also 0, the count will not be affected. Now again you move this 3 part, and this is the 2 part, right? It means the fifth part is neglected, and this oneth part is added in my window. So 1 is added, it means this will be count as 3, right? Right. Now again when you move to this, the 2 here, and this 3 is here, right? So if you move like this one, the sixth one has decreased to 2, and when you come to this, 1 is added, so again count will be 3. So this is how we will traverse this, right? I hope you understood it, how we are traversing, right? So basically just we need to implement this one, the sliding window. This is just a simple sliding window question, and just include it, right? Let's implement it, right? So this is nums.size, and what we will do, we will count the total number of ones, right? So total one, right? So that would be zero, start from zero, and auto x nums. So what I will do, I will just add this x in my answer. So if it is zero, that will not affect. If it is one, it will get counted, right? So I will add all the ones. Now I need to find the starting window, right? I need to find the starting window. So this total is one is x. So I need to find the starting window. So starting window would be, let's take it as count as zero, and the starting window would be the total one, right? What I will do, I will start iterating from zero till total of one plus plus. Why I'm doing this? Because at the starting window, the maximum oneness can be the total one, right? So if it is present in all together from starting from zero to index, then it will be added, otherwise it will give me some other group, right? So what I will do, I will just add like this nums I, okay? This will give me the starting window, the starting window count of one. Yes, one is right. Now what I will do, I will start iterating from where. So till total one, I have calculated the count, right? Now I need to start from the total one. So let's make it as k, right? Let's make it as k. Right? This total one will be k, right? So I have changed the variable which was here, right? So this total one will be k. This is k, right? And till where we will iterate, till k. Why am I iterating? Because it is a circular subarray, right? And the maximum iteration can be goes to n plus k, right? That's why I have done this. Now what we need to do, we will just shift the windows. So how we will shift, we will just decrease if there is previous is 1. If the previous I minus k position is 1, so we will decrease it. And if the current I is 1, so we will add it. And after this, we will need to maintain the maximum count. So let's take it as a maximum count also, which is mx, and that will be the count. This is the initial count, which is 0 to total 1. This is just a sliding window, right? This is maximum, and this is the count we will need to store, right? So now we have stored all the maximum value, max count of 1s. Now we have the max sub array length of 1s, right? And now what we need to do, we need to just minus it with my total one, which is this total one minus mx, right? And that will be my total number of swaps, minimum number of swaps, right? This is the total, this is the max which is grouped together, and total will be the swaps which will need to group all the together. This is how we solve this question. Let's just run this and let's see if we have a compilation error or not. Okay, we have something. Yeah, one thing is to note that we are moving out of the bound condition here, and I have told you that we need to check for I modulus n, right? Because it can go out of bound. So I will check for I modulus n, right? Also here, this can also go to out of bound, so this will also need to be I modulus n. So yeah, this is how we solve this question. Let's just run this. Yeah, we have passed the sample case. Let's submit it. We have passed all the test cases, right? So if you see, what will the time in the space complexity? So basically it is just a sliding window. You need to figure out how is a sliding window, right? Because we need to group together all the ones, and then the ones which is not in the group should be swap it, and one swap is all it takes to move from any position to any position in the array. So this will be total one minus mx, and you need to just find the mx in the circular subarray. That's the question. So let's analyze the time complexity for this question. So where this is, first thing is to note the all the total counts, that will be O of n for sure, right? The second thing, we are iterating from the total one till O of n plus k. So that will be, can be O of n plus O of k. And what is k here? K is the total number of count of one present in array, right? And is the length of array, and is the size of the array, right? So basically, the overall time complexity will be O of n plus k, right? O of n plus k, right? And the space complexity would be, so I have not taken any extra spaces. You see, that's all our variables. So, but if you take O of 2n instead of n plus k, that would take, that we need to take store all the extra duplicates this nums to extra, so that will take O of n plus. But here we haven't taken any extra spaces, right? We have just used our variables, so O of 1. So this is how we solve this question. Hope you understand it. Hope you understand it. Thank you so much. Bye bye.